Welcome back to the Deep Dive.
Great to be here.
So today we're looking at something pretty interesting. It's source material from the Hello Algo podcast finale.
Right, the one that wraps up their whole series based on that open source book.
Exactly. And our mission really is to unpack how they summarize this whole journey through data structures and algorithms.
And especially that idea they float,
Hmm.
that mastering this stuff gives you a kind of superpower as a coder.
Yeah, that's the hook. So let's dive in. The summary, it takes us right back to the start. What is an algorithm?
Fundamentally, yeah, just a set of steps, right, to solve a problem.
But they immediately stress understanding efficiency. Why is getting your head around big O notation seen as like the absolute bedrock?
Well, big O it's how you predict performance, how your code's resource use time. Memory scales up when the input gets bigger.
Okay.
Think about it. A solution might seem fine with 100 items, but what about 1,000,000 or 1 billion?
Right, massive difference.
Without understanding Big O, building stuff that's actually scalable and reliable, it's just really, really hard. It's, foundational.
Makes sense. So from that foundation, the source then moves into the data structures themselves. Covers quite a range
Yeah, the toolbox.
and highlights those trade-offs you always face, like arrays versus linked lists.
The classic example. Arrays give you that fast access if you know the index, because the data's all together in memory.
But adding or removing stuff can be slow.
Exactly. Whereas linked lists, using pointers, well, insertions and deletions can be quicker in certain spots, but getting to something specific by index, slower.
So the source really hammers home. Why isn't there just one perfect structure?
Because the choice matters so much for the problem you're solving. It affects efficiency, how complex your code needs to be.
Right.
Picking the right tool, whether it's a stack for, say, function calls, or maybe a tree for fast searching, or a graph for networks, it's often essential.
It's not just nice to have, it's critical. Okay, so you've got the right structures. They need these strategies, the algorithms.
Mm-hmm.
The summary touches on the basics, like searching and sorting,
Mm-hmm.
but then gets into these bigger paradigms, things like divide and conquer.
Yeah, powerful stuff. Breaking a big problem down into smaller, sort of identical pieces you solve recursively.
And the source says these aren't just, academic things.
Not at all. Practicing these really trains you to think algorithmically. It helps you look at a problem systematically, evaluate different approaches.
Based on efficiency, suitability,
Exactly. You start seeing the patterns.
which kind of brings us back to that big idea from the finale, this superpower you gain.
Yeah, and I like that framing. It's not literal,
Well,
obviously.
no flying involved.
Oh, no. But it's the power to write code that's not just working, but efficient,
Yeah.
elegant, scalable.
How does that power manifest, practically speaking?
It's about looking at a complex problem and sort of instinctively seeing the potential structure as the best algorithmic fit. And the source really pushes practice, right? Applying these concepts, seeing the patterns everywhere, using resources like the Hello Algo book or the community. That's how you sharpen it.
So tying it all together for you, the listener, where does this fit in your coding journey?
Well, the source is pretty clear on its relevance.
Yeah, it stresses that whether you're prepping for interviews, building projects, or just aiming to be a better programmer overall, this stuff is invaluable.
Absolutely.
And that final advice they give, it's simple, really. Stay curious
Keep asking questions.
and keep coding.
Definitely. It's a continuous process.
So a really valuable dive into why these fundamentals matter so much.
For sure. And maybe a final thought to leave you with. If an algorithm is just a set of instructions for a task, how many complex algorithms are you already running or even creating in your everyday life? Totally outside of coding, without even thinking about it. Something to ponder.